Hello, everyone. Today we're talking about Chemistry Honors Unit 3. So starting with the summaries and vocab, you can skip after those. So Unit 3 of Chemistry covers many different periodic and elemental things, but can ultimately be categorized under the term periodic table. In this video, we will cover families on the periodic table, metals, nonmetals, metalloids, and periodic trends. Periodic families show us how elements are organized in relativity to reactivity. These elements can be categorized into metals, nonmetals, and metalloids, each category having their own unique characteristics. Lastly, periodic trends show how the periodic table is organized based on different atomic features, such as ionic size, atomic size, electronegativity, and ionization energy. So some additional vocab. Periods. Horizontal rows, 7 periods on the periodic table. Groups, vertical columns on the periodic table. Tall groups are all numbered 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And shorter valley groups are numbered from 3B, 4B, 5B, 6B, 7B, 8B, 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 1B, and 2B. There's 18 groups total. Transition metals. Any element in the D block of the periodic table, which includes groups 3 to 12 on the periodic table. So luster, ductile, malleable, and conductors all are relative to metals. So luster is their shininess, ductile can be pulled into wires, malleable can be flattened into a sheet, conductor can conduct electricity, allows the passage of a charge. So now starting, families of the periodic table. Alkali metals. Group 1A. They react vigorously with water. Example, lithium and potassium. Alkaline earth metals. Group 2A. They are reactive, but not as much as the alkali metals. Examples include calcium and radium. Halogens. Group 7A. Very reactive and react with most elements. Examples, chlorine and iodine. And noble gases. Very non-reactive and are rarely found in combination with other elements. Examples, helium and neon. Metals, nonmetals, and metalloids. Metalloids. Metalloids make a stair-step line on the periodic table. They have properties of both metals and nonmetals and are better conductors of heat and electricity than nonmetals are. Examples are silicon and arsenic. Metals. Everything to the left of the stair-step, everything in blue on the screen. Properties include luster, ductile, malleable, good conductors of electricity, and solids at room temperature. All metals are solids at room temperature except for mercury. Examples are lead and copper. Nonmetals. Everything to the right of the stair-step. Properties include no luster, not ductile, not malleable, and not good conductors. Examples are hydrogen and carbon. Periodic trends. The first periodic trend includes valence electrons and ionic size. Valence electrons are electrons on the outermost energy level of an atom. The periodic table tells you the number of valence electrons that are present in the atoms of each column. Group 1A has 1 valence electron. Group 2A has 2 valence electrons, and that includes all the way up to group 8A, which has 8 valence electrons. Example, fluorine has 7 valence electrons since it is in group 7A. Ionic size. Ionic size is the size of elements that have gained electrons, anions, or lost electrons, cations. Cations are smaller than the parent atom, and anions are bigger than the parent atom, seeing as anions gain an electron and cations lose an electron. Ca plus 2 is smaller than Ca, since it is losing electrons. And F negative 1 is larger than F because it is adding electrons. Periodic trends, atomic size. Atomic size, the distance from the nucleus to the valence outermost electron. Size increases going from top to bottom, and size decreases going from left to right. An example would be between hassium and indium. Hassium is farther left, and down on the periodic table, making it larger than indium. Periodic trends, electronegativity. Electronegativity is the measure of how strongly an atom attracts bonding electrons to itself. Electronegativity decreases going from top to bottom and increases going left to right. Example, when comparing oxygen with sulfur, oxygen has more electronegativity because it is higher on the periodic table. And last of the periodic trends is ionization energy. Ionization energy is the energy needed to remove an electron from an atom. Ionization energy decreases going from top to bottom and increases going from left to right. An example would be when comparing helium to beryllium, helium has more ionization energy because it is higher and more right on the periodic table. So that's everything you need to know from Unit 3, the periodic table from Chemistry Honors. Bye!